Okay, so for the first part, we're gonna start from the PC, and we can see here that the clock is fed into the PC, and here the PC is an FSM that uses both combinational logic and sequential logic to count up from 0 to 7, and the output of the 0 to 7 is a 3 bus, and then this then fed into the decoder over here, and such that the 0 to 7 3 bus is converted to a 2 to the power of that 3 bus output, where the PC output determines which bit is high. So one of these will turn high, and then that is fed into the read-only memory or ROM, which is made of NMOSes such that depending on the high bit of the decoder, will send the instruction to the other components, where each bit is the tells the instructions for each every single one. And so, for example, the load, we are writing to the register. So the write here goes high, and allowing the register file to load data from the memory when the clock is also high here, such that these clock regs are high depending on which one we specify from the instruction. Um, yeah, so we send that to the register file, which is then also made of flip-flops such that the specified register from the instruction can save data into its respective flip-flop depending on these, which we determine from there. We then move on to the memory here, uh, which is made of inverters and NMOS and CMOS logic over here. Here we take in the address, data address, and send it out to the mux from mem data out into the data select mux, which is located over here. This is the muxes are made out of combinational logic, and they send that data into the register, seen by this arrow, and then it is saved depending on what we said before about the clock register um, signal. For add, it's a little different, but we start at the PC again and get the add instruction from the instruction memory. And again, the write signal here is high, such that we select the register to write to, like mentioned before. We then look at the muxes located before the ALU, which right here, which are the select muxes, and those determine the inputs to the ALU. And since we're doing addition, we go to the add block and we select that data through the mux again. Um, and in addition, the add block is made again of combinational logic. And then this output, the data path out, is sent to the data select mux again, and then that is saved into the register file um, due to these clock register file that or clock depending on which register you want. For multiplication, it's essentially the same, except instead of selecting the add, we're gonna now look at the multiplication, and this multiplication block is also made of combinational logic, and then we again send it back to you so we can save it back to the register file. For store, it's a little bit different. We're now looking at the select muxes only at this part, the top, and depending on which one we select, we get that data from that top part, and then we also get the data address, and this time we also get mem right, so we can get the or so that we can write to the memory, and yeah, and then so now that data will now be stored in the data memory, and that's basically how the computer works for those four basic instructions.